Hi students, so welcome to the session. I am Dr.K.Varada Rajkumar, Associate Professor, Department of CSE-AIML, so MLR Institute of Technology, Hyderabad. In our previous 3 classes, we discussed about single linked list concepts, how to create a node, how to insert a node in single linked list, how to delete a node from the single linked list. In this class, we are going to learn about how to implement all these functions in C programming. So, overview of the presentation, we are going to implement insert function. Insert function have 3 cases: insert at beginning, insert based on position, insert at the end of the list. And we are going to implement a delete function. Here also we have 3 cases: delete a node at the beginning of the list, so delete a node in specific position, and delete a node from the end of the list. Okay, and we implement display function to print all the elements in the single linked list. So outcome of this lecture, at the end of this lecture, you all are implement single linked list program in C programming. So this is the program. So this is the node structure, and this is the function to create a node. So already we discussed in detail in our previous classes. Here struct node means one node. So this node have 2 parts. One is to represent data part, another one is next part. So this we are going to use to represent the address of next node. And create node function is used to create new node. One new node is created, and in this node we insert the data and make the next as a null, and when we create a node it has some address. So this address will return to the called function. That is the purpose of create node. Already we discussed in detail about the create node in our previous classes. So this is the function for inserting a node at beginning. So this is the function to insert node at middle. Okay, here, so this is the actual function. So this is the actual function. So what we discussed in our previous classes. Here we are taking another condition, position less than or equals to 0. Here we are trying to insert a node, so based on the position. Now the position must be from 1 to n. Okay, if there are 5 elements, then we are going to give the input 1 to 5 only. If we give 0 or any negative values, then we are going to check the position less than or equals to 0, then we are going to print a message invalid position, node not inserted. Okay, and if the position equals to 1 now, then we are going to check the condition if position equals to 1 and head equals to null. That means that you are going to insert a node as beginning of the list. So insert at beginning, the same code we write here. Okay, so this is the code to insert an element at the end of the list. Here, for example, I select insert at end, but the head is null, head equals to null. So what it is? Now whatever you are trying to insert a node at the end of the list, that is a first node, that is the first node. So here also we are going to write the same code what we write in insert at beginning. Okay, the remaining we discussed in our previous class. So insert at end of the list. Okay, so next function is delete at beginning. Now in this case, if I try to delete a node that is present as a beginning of the list, then so this is the code. Okay, but for example there is no list, but you try to delete an element, then what is the condition? The head equals to null. If head equals to null, then we assume that list is empty. So we print the message list is empty, cannot delete. So this is the function to delete a node at a specific position in the list. Now here same, if the position if I enter less than or equals to 0, then I am going to print invalid position, node not deleted. Here we are going to specify some position p. If there are 5 nodes, then we are going to enter the p value from 1 to 5. If I enter p equals to 0 or any negative values, then we are going to check it is less than or equals to 0. So we are going to print invalid position, node not deleted. If head equals to null, another condition is there is no list created, but you are trying to delete an element from the list. In that case, we are going to check head equals to null. Yes, if it is equals to null, we are going to print so list is empty and cannot delete. Now if the position what we enter is 1, so position equals to 1, now p value equals to 1. In this case we try to delete the node at the beginning of the list. So we are going to write the same code what we write in delete at beginning. Okay, this is for delete in a specific location. Okay, so this is the code for delete at end. Here we are trying to delete a node at the end of the list, but head equals to null. If head equals to null, it means that there is no list is empty. So we print list is empty, cannot delete. Now if there is only one node, then we try to delete that node. For example, this is the only one node, 1001 is address, 11 is the data, and the next pointer is null. In this case, so we are going to delete the node. So if head arrow next equals to null, simply we delete this node. So we write free head, and I make head equals to null. Okay, so this is for to traverse to last node. To identify, here we are going to delete a node that is present at the end of the list. So we are going to traverse. Okay, so already we discussed in our previous class. So this is the function display. In display we are going to print the data. So print the data. So data present in the list. So we traverse from head. We are going to take head as initial value. Here we store the head in current, and we traverse until the current is null. Okay, so now pause the video, try to construct the single linked list. So based on these instructions. Okay, here what is the first instruction? Insert at beginning, head 333. So this is the node created, and the head equals to, and the data is 333, and here so this is the null, and let us assume this is the address. Now head equals to 1001. Okay, next instruction, insert at beginning, head 322. So another node is created. So this is the data, and make this as a 2001 as address. So we insert this node as a beginning. So 1001, that's it, and I make head equals to 2001. Okay, again insert at beginning, head 111. Another node is created, data is 111, and let us assume the address is 3001, and this is the link. So head 2001, and make this head as a 3001. Okay, next instruction, insert at beginning, head 999. Now another node is created, the data is 999, and let us assume that address as 1010, and the head is 3001. That's it. Make this as a head equals to 1010. Okay, next instruction, insert at beginning, head 666. Another node is created, 666 is the data, and let us assume the address is 5001, and what is the head? 1010. So this is linked like this, and make the head equals to 5001. That's it. Okay. Now insert a node at the middle. Now here I am giving 1, 2, 3, 4. So 1, 2, 3, 4, 5. Here I am giving 1, 2, 3. I want to insert this 1, 2, 3 as a fourth node. Now here in this place I am going to insert 1, 2, 3. And let us assume this is 6001. Now I store 2001 here. So this is the link. And here in the place of 2001 I am going to store 6001. So this is the link. That's it. Now 1, 2, 3, new node is 4. This is the 5 and 6. Okay. Here again I call insert 103. Now this is the 1, 2, 3. So in this place one new node is created and the data is 100 and the address is 3001. I store here. So this is the link. Let us assume the address is 7001. In the place of 3001 we write like this. That's it. Now 1, 2, the new node is 3. Okay. Now insert at the end here. So this is the end. In this place we are going to store 555. Let us assume the address is 8001. In the place of null we are going to store 8001. Here this is the null. Okay. Next instruction, insert at end 888. So again one node is created. Let us assume 9001. In the place of null 9001 and link and make this as a null. That's it. Now so linked list I am going to display. So what it display? It display what is the first node? So how we know? Head 5001. So 5001 666. Next one 999. Next one 100. After 100 111. After 111 123. After 123 222. After 222 333. After 333 555. After 888. After 888 null. So this is the expected output for this instruction. If I call display, so this is the expected output. So let us execute this program. If you observe that, so this is the output 666, 999, 100, 111, 123, 222, 333, 555, 888 and null here. Okay. So next instruction is delete. Deleted beginning. Now so this will be deleted and the address of 5001 next is 1010. So in the place 1010 now. After that delete at middle 3. Now this is the 1. So this node is deleted. Now this is the 1 now. 1, 2, 3. Here I give the position as a 3. So this node will be deleted. And deleted end. So this node will be deleted. Now I print the elements using display function. Now what it display? It display the starting. The head value is 1010. So it prints 999. After 999 100. After 100. So this is the 1, 2, 3. Why? So third node is deleted. So next one 222. Next one 333. Next one 555. Here this node is deleted. So in the place null pointer. So after 555 null. That's it. Now we execute this program. Now if you observe, so 999, 100, 123, 222, 333, 555 and null here. Okay. I hope you all are understand. So how to implement single linked list. Summary of today's lecture. We implement insert function, deletion function and display. In insertion we have 3 cases: beginning, middle and end. In middle we are going to specify the specific position to insert a node at a specified location. So similarly delete also, we delete node from beginning of the list, and we delete a node from middle of the list, and we delete a node from the end of the list. For to delete a middle element also, we are going to give the we are going to specify a particular position. So display function is used to display all the elements present in the list. In next class we are going to learn about double linked list. Thank you.